Hi, everybody. Happy Friday. So today, your first homework assignment is to remember you submit the first attempt by midnight. After the midnight, you can still continue to work on your homework until you get perfect scores. Alright, everybody? So, did you receive my email? That yes, for some of the problems, if you enter three decimal places, they mark you wrong. Just continue to enter the full string. Okay, everybody? So yeah, when I make the homework assignments in my open math. So my open math has a question bank and it has a lot of questions. So I include those questions in the homework, but I'm not able to edit the problem because I did not create a problem. So, but from now on, if you enter like three decimal places, they still mark you wrong. Please try to enter the full string. Okay, everybody? So that's the homework. Do you have any questions about the homework? So are you able to see the homework solution and some of the video of some problems so you can understand it? Yeah, feel free to ask me questions. Okay, so today we continue on session 7.2. So last time we talked about the sixth trig function, right? Do you still remember? So, ka, to. What is so? Sine is opposite over hypotenuse. Ka. Cosine is adjacent over hypotenuse. Everybody open your mouth. To. Tangent is opposite over adjacent. So practice this many times, okay? And how about the remaining three trig functions? We have this hexagon, right? And then the way how we write down the trig functions is the way how we pronounce them, right? Sine, cosine, tangents, cotangents, secant, cosecant, right? And then we have the diagonal rule. The product of the two ends equals the middle one. So sine theta times cosecant theta is 1, right? And then cosine theta times secant theta is 1. Tangent theta times cotangent theta equals 1. Okay, so have this picture in your mind. And when I ask you, okay, what is secant theta? 1 over cosine. What is sine theta? 1 over cosecant. Cotangent theta? 1 over tangent. Okay, everybody? So be familiar with this formula. So that's why. What's cotangent? The reciprocal of tangent. That means you swap the numerator and denominator. Yeah? So you have adjacent over opposite. Okay? And then secant theta is 1 over cosine. Yes? Cosine. Where is cosine? Adjacent over hypotenuse. You swap them. So you get hypotenuse over adjacent. Yes? And then cosecant theta is reciprocal of sine, swap them. You get hypotenuse over opposites. Okay? So next Monday, at the beginning of the class, I will print out this exactly blank sheet and you guys fill it out. It's not count for scores, but if you don't get them all right, I will ask you to come to my office and keep doing it until you get them all right. This is so important. Okay, this is trig course. It's so important. Get familiar with this. Okay, so that is when we have a right angle triangle. How about if we draw this triangle on the xy plane? Remember, the initial side is always the positive x-axis, right? And then your angle rotates. Okay, so if you rotate counterclockwise, we have positive measure. If you rotate clockwise, we have negative measure, right, everybody? So let's say our angle is theta. So this is the angle theta. By the way, we know that theta could be bigger, 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 so you can wrap around the circle. So the picture is not just in the first quadrant. It could be in the second quadrant, the third quadrant, or the fourth quadrant. But it's just your x and y in your first quadrant. Your x is positive, right? And then your y is positive. But when you go to the second quadrant, your x is negative, your y is positive. The third quadrant, x is negative, y is negative. The fourth quadrant, x is positive, y is negative. Okay, yes. So to make things simple, let's just have the picture like this. Okay, now sine theta. Sine theta is what? Opposite over hypotenuse. What is opposite? Y. Yes, everybody? So once you remember this, you draw the picture. You know, x is the horizontal distance, y is the vertical distance, and this, the hypotenuse, is the r. And do you remember the size of a right angle triangle? We have the Pythagorean theorem. Yeah? The Pythagorean theorem tells us that the r squared equals x squared plus y squared. Do you all remember Pythagorean theorem? Mm-hmm. Therefore, the r is square root of x squared plus y squared. The r is the distance from the point to the origin. The r is always positive. I mean greater or equal to 0. If the point is at the origin, r is 0. But if the point is not at the origin, then r must be positive. Okay? Mm-hmm. Yes. So, yeah, sine is opposite over adjacent. Opposite is what? Oh, sorry. Opposite over hypotenuse. Yeah. Opposite is y. How about hypotenuse? R. Yeah? Okay. How about cosine theta? X over R. Tangent theta. Y over X. Cotangent theta. Yeah, x over y, because that is the reciprocal of tangent. Okay? Reciprocal of tangent. So x over y. Secant is the reciprocal of what? Cosine. What's the reciprocal of cosine? R over x. Yes, everybody? How about cosecant? Reciprocal of sine theta, which is r over y. So far, so good? Okay. So be familiar with the definitions of the 6 trig functions. Okay, Monday I will give you a blank sheet. You're gonna fill those out. Okay, don't worry about the triangle formula right now. Okay, so just remember these and the reciprocal identity. Okay, let's continue. So that is 7.2. We have all the 6 trig functions. And when you write down the trig functions, don't forget the theta. So, because the theta really matters, okay? So the sine theta That's the angle. So with the trig functions apply on the angle, and the output is a ratio of two sides of a triangle. Okay, so attendance here. Okay, thank you. So the trig function is a machine, right? You have the input. The input is an angle. So make sure you have the angle theta. And then you have your output. Your output is a ratio of two sides of a triangle. Okay, of two sides of a right angle triangle. So the trig function is a function. It has inputs and outputs. Input is an angle, and the output is the ratio of two sides of a right angle triangle. Okay, now let's practice. Bless you. Find the six trig functions of an acute angle using 36, 77, and 85 right triangle. Okay. So let's draw pictures. Let me use orange. Okay, let's draw a picture. It's a right angle triangle. And 36. The smallest side is 36. So I can put 36 here. And the bigger size, 77. The longest side is 85. Right, everybody? So let's check. Do they satisfy the Pythagorean theorem? It's 36 squared plus 77 squared equal to 85 squared. Take out your calculator, everybody. So, in your calculator, what is 36 squared plus 77 squared? So 7225. Okay. 7225. How about the right hand side? What is 85 squared? Yeah, good. Check. They're really a right angle triangle. Okay, they satisfy the Pythagorean theorem. Good. Now we write down the acute angle. Let's say, the problem is we have two acute angles, right? Both of them are acute angle. And let me just pick this one as theta. Okay, let's put this one as theta. Okay, so if this is theta, what do you say this is? Opposite, adjacent, or hypotenuse? Opposite. And how about the 77? Adjacent. The 85? Yeah, hypotenuse. Okay, now sine theta is what? Opposite over hypotenuse. Can I just put OH? Yeah, to save some time. What is O? 36. What is H? 85. Okay, now everybody do the rest. You don't need to plug in your calculator. Just leave it as a ratio like that. Don't need to plug in your calculator. So find all the six trig functions. You have sine, cosine. Make sure you have the theta. You have the worksheet 7.2. Yes, this is 7.2. Oh, it's good. Oh, so this is a 7.2. Oh, you have the worksheet. right, what is cosine theta? How about you guys take turns to answer my question? How about we start from that side? Hi, Joe. What is cosine theta? Cosine theta is adjacent over hypotenuse. And what was adjacent? 77 over 85. Okay, right? And next, tangent theta. What's tangent theta? Opposite over adjacent. Opposite is 36 over 77. And now, cotangent is the reciprocal of tangent, which is, adjacent over opposite, which is 77 over 36. So once you figure out those three, and the remaining three is the reciprocal of this three. Cotangent is the reciprocal of tangent. So you can just, and then who is the reciprocal of cosine? Secant. So you put secant theta here. What's the reciprocal? 85 over 77. Yes, everybody? And what's the remaining one? Cosecant theta is the reciprocal of sine, which is 85 over 36. So I suggest when you write down the sixth trig function, follow the order: sine, cosine, tangent, and then cotangent, secant, cosecant. Okay, so follow this order. Find the first three and then find the reciprocal. Is that clear, everybody? Mm-hmm. All right. Okay, so and then trig functions values of special angles. Do you remember last Monday or last week? We have the full circle, and then we look at the multiple of 30 degrees and multiple of 45 degrees. So those are the special angles. Okay, so let's first look at 45 degree. The 45 degree angle can be derived by thinking of an isosceles right triangle. Compute the length of hypotenuse for the triangle below. Then use the side's length to derive all the trig function values for the angle of 45 degree. So 45 degree. Okay, now we know this side is equal to this side, and this is also 45 degree. Right, everybody? Okay. What is the hypotenuse? By the Pythagorean theorem, it is, square root of 1 square plus 1 square, which is square root of 2. Right, everybody? Okay, so let's focus on this angle. Let this angle be our theta. Then what is our opposite side? Right here is 1. Our adjacent side is also 1. And our hypotenuse side is square root of 2. Okay. Now, how about you continue to tell me the answer one by one. Okay, we take turns. So everybody has a chance to tell me your answer. And please imagine we are a big family. So sometimes if you don't be afraid of saying something wrong, because sometimes I make mistakes too. So we are human beings, we might make mistakes. So just think about we are family members. Okay? Sisters and brothers, so don't be afraid. Okay, we love each other. We help each other. Let's grow. Okay, so sine opposite over hypotenuse. Hi, what's the number? What's opposite? 1 hypotenuse. Square root of 2, right? So we have 1 over square root of 2. You can leave it like that, or sometimes people like to write square root of 2 over 2 because they don't like the denominator to have an irrational number. Okay, but they are the same. Yes, because you multiply the numerator and the denominator by square root of 2, and then the bottom is square root of 2 times square root of 2 is 2. Okay, so they are the same. Next student. Okay, how about from you? What is cosine 45 degrees?
1 over root 2.
Yes, also 1 over root 2. Okay, next student. What is tangent 45 degrees? 1 over 1. Ooh, so that is 1. Good. Next student. Cotangent 45 degrees. Cotangent is the reciprocal of, yeah, it's 1. Reciprocal of 1 is 1. Secant theta is the reciprocal of cosine. The reciprocal of that is, yeah. Yes, very good. The next student, how about cosecant 45 degrees? Yes, also square root of 2 over 1, which is square root of 2. Questions?
Is it okay to have the radical?
For our class, yes, it's okay. It's okay. Yeah. I won't be so strict if you have to rationalize it. And for me, I would prefer this because I feel like this one you can cancel something, and here you cannot cancel. So for me, I really prefer this. I think this is simpler than this. They don't have numerator denominator. Yeah. Okay. So yes, we have this 45 degree. Okay. The trigonometric values of 30 degree and 60 degree angle can be derived by thinking of the triangle form from the following. Okay, so we have this triangle. You know this side is 2, this side is 2, this side is also 2, right? So because all the 3 sides are the same, therefore all the angles are the same, right? And you know the sum of 3 angles is what? 180 degree, and 180 degree divided by 3 is 60 degree. So we have this is 60 degree, this is 60 degree, and because this one is 60 degree, and what's the 60 degree divided by 2? 30. This is 30 degree, this is 30 degree. Good. Now, let's see. Okay, let's focus on this right angle triangle. Okay, how about use okay, how about use green? Okay, we focus on this one. Okay, so we focus on this one. You see, we have the hypotenuse is 2, and this side is 1. How do we find this side? The square root of the 2 square minus 1 square. Is everybody okay with that? Because by the Pythagorean theorem, okay, if you have like x, y, and r, you know, x squared plus y squared is r squared, right? So to find r, your r is square root of x squared plus y squared. But if you want to find the x, well, your x squared is r squared minus y squared. Therefore, your x is plus or minus. Whenever you take square root, plus or minus, r squared minus y squared. But because in this case, this side is positive, right? So we only take the positive square root of the hypotenuse, 2 squared minus 1 squared. What is 2 squared? 4. What is 4 minus 1? 3. Oh, so this side is square root of 3. Okay. Now, let's look at the 60 degree. 60 degree. Let's call this is theta. That's 60 degree. Who's the opposite? Square root of 3 is the opposite. Right? So we write it down. Okay, that's the opposite. The adjacent is what? 1. The hypotenuse. 2. Good. Let's continue. Next student. What is sine 60 degree? What's the opposite? Yes, good. Square root of 3 over 2. That's good. And then, next student, hi. What's cosine 60 degree? Yeah, adjacent is 1 over hypotenuse is 2. Next student, tangent 60 degree. Yes, very good. Square root of 3 over 1, which is square root of 3, right? Okay, next. Jeremy, how about cotangent 60 degree? Good, the reciprocal of tangent. So 1 over square root of 3. Next, secant 60 degree. 2 over 1, which is 2. Good. Okay, next, cosecant 60 degree. Yeah, 2 over square root of 3. Very good. And you can just leave it like that. You don't have to rationalize your denominator. Okay, you can leave it like this. So now we get the special angle values, the 60 degree for all the 6 trig functions. Any questions about this? All good? Okay, now we look at the 30 degree. Okay, let's use which color? Let's use purple. Okay, 30 degree. Look at this picture. 30 degree is right here. Now, our theta is 30 degree. Then who's my opposite? 1. Oh, the opposites is become 1. How about the adjacent? Yeah, the adjacent becomes square root of 3. But the hypotenuse is remain the same. Right, everybody? Okay. So next student, what is sine 30 degree? 1 over 2. Yes, 1 over 2. Right, everybody? Next, cosine 30 degree? Square root of 3 over 2. Good, square root of 3 over 2. And tangent 30 degree? 1 over root 3. Yes. Everybody okay with that? Okay, so cotangent 30 degree. I go back to you. What's cotangent 30 degree? That's the reciprocal of. And this is the reciprocal of tangent. Yes, square root of 3 over 1. Yes. Square root of 3 over 1. And secant 30 degree. 2. Yes, very good. So secant is the reciprocal of cosine. Where's cosine? Right there. So 2 over root 3. And cosecant, 30 degrees. Yes, 2 over 1. See? It's the reciprocal of sine. Okay, so we get 2. So we fill out all the values. Okay, everybody? All right. So now we get the table for the common angle values. So this is in radian, right? In degrees, they're gonna be like 0 degree, 30 degree, and 45 degree, 60 degree, and 90 degree. Okay, everybody? Okay, so could you go back to your worksheet and tell me what is sine 45 degree? So look at your previous page. What is sine 45 degree?
1 over square root.
Yeah, 1 over square root of 2. Yeah, let's write it down. 1 over square root of 2. And cosine? Theta, cosine 45 degree is the same. Tangent, 45 degree is 1. Cotangent, 1. Secant, square root of 2. Cosecant, square root of 2. Yes, everybody? Just copy down the number here. All right. How about 30 degree? Okay, we'll just go back here. 30 degree. What's sine 30 degree? 1/2. Yeah, 1/2. And then root 3 over 2. Tangent is 1 over root 3. Cotangent, root 3. Secant, 2 over root 3. Cosecant, 2. Yes, everybody? 60 degree. 60 degree right here. So we have root 3 over 2 cosine 1/2. And the tangent is square root of 3, and cotangent is, let's see, where's cotangent? 1 over root 3, and then secant 2, cosecant 2 over root 3. So far, so good, everybody? So we can fill out the table for these 3 columns. Okay. So next session, when we talk about the point on the unit circle, we'll also talk about how to fill out this column and this column. Okay. And there are ways to help us memorize the number. Okay, so you don't need to write out right now. Next class, after we study this column and this column, I will teach you a trick to fill out all the numbers in this table. Okay. So let's keep going. Do you realize in our example, sine 60 degree is the same as cosine 30 degree? Do you realize that? Because 30 degree and 60 degree, they are complementary angle. So the adjacent of the 30 degree is the same as the opposite of the 60 degree. Yes, everybody found this picture. So we can actually generalize this idea and get cofunction identities. Let's do. For any acute angle A, sine A is equal to cosine 90 degrees minus A. So therefore, sine 60 degree is cosine 30 degree. Right, everybody? And this is true for all the cofunctions. So sine and cosine, they are cofunctions. Secant and cosecant, they are cofunctions. Tangent and cotangent, they are cofunctions. Okay, everybody? So therefore, if I ask you, okay, what is secant 40 degrees? That is cosecant 50 degrees. Yes, everybody? Mm-hmm. Okay. So yes, this is the cofunctions. It's equal to the complementary angles. Okay, so let's continue. Practice. If sine t is 5 over 12, what is cosine pi over 2 minus t? By the way, what is pi over 2? 90. So this is 90 degrees. Let me get back my orange color. Okay, so cosine 90 degree minus t is the same as sine t. Therefore, we get 5 over 12 by the cofunctions identities. Okay, and what cofunction and the angle here, they are complementary angle. And remember, complementary angle is you add them up, you get 90 degree. Supplementary angles are you add them up, you get 180 degree. Okay, good. So, next example. Find the unknown side of the triangle. Okay, so yeah, then let's see here. Once you know, so from now on, you remember for 45 degrees right angle triangle. The relation is 1 square root of 2. Okay? If I change one of the sides, to be 4, they have the same ratio. If this is 4, what's this? 4. Yes. So they have the same ratio. 4, 4, and this is 4 square root of 2. Okay, everybody? They have the same ratio. And now, because we have the 60 degree, then we have what? 1, 2, square root of 3. So keep this in mind. Therefore, if you see something like this, you see the shortest side is 7, then you kind of multiply everything by 7. What's this? 2 times 7 is 14. And how about this? Yeah, exactly. So A is 7 times square root of 3. Is that okay, everybody? So once you know 45 degree and 60 degree or 30 degree, you draw these two triangles. And all the sides, they have the same ratio. So you just compare. Oh, okay. If this is 4, I get this. If this is 7, and then I get this. Okay? So let's do more exercise. Okay, if I give you, this is 45 degree, and let's say this is 13. What do you do? What's this? 13. And how about this? 13 square root of 2. Good. How about the same one, but I give you this guy is 13. What do? You see from here to here, you multiply by square root of 2. Then from here to here, what do? Divide. Exactly. Right, everybody? We divided by square root of 2. Therefore, you get what? 13 over square root of 2. And this is also 13 over square root of 2. Everybody know that trick? The ratio 1 square root of 2. But if you get this first, you're going to divide it by square root of 2. Yes. Okay, how about one more? I give you, let's say, this is 10. Okay, if I get this is 30 degree. If I give you that is 10. What's this one? 5. Yes, the hypotenuse. Okay, it's 2. And then the adjacent, the shortest side is half of the longest side. So if this is 10, then this is 5. And how about the side? Yes, very good. Okay, oops, sorry. Let's do one more. This one is harder. Okay, also, this is like 60 degree. Let's say I have, now this is 10. This is 10. Think about it. Here to here, you multiply by square root of 3. And from here to here, what do you do? Divide by square root of 3. Is everybody okay with that? So we know the ratio, and then we compare. We know this side is longer than that. We multiply by square root of 3. So if you go backwards, you divide it by square root of 3. And how about this? Yes, it's 2 times the shortest side. So 20 over square root of 3. Okay, everybody? Mm-hmm. So, this trick, you can actually extend the trick. Do you know that there are more right angle triangle? For example, 3, 4, 5. Do you know the 3, 4, 5 is a right angle triangle? Because 3 square plus 4 square. What's 3 square? 9. 4 square? 16. 9 plus 16 is 25. 5 square. 25. Yes. So it satisfies the Pythagorean theorem. Okay. So 3, 4, 5 satisfy the Pythagorean theorem. Therefore, if I give you the same one, I give you 6, 8. What is the other one? 10. Right? They follow the same ratio. So you can kind of multiply the ratio and get that. Another one I can think of is let me see. Is it 5, 12, 17? Oh, 5, 12, 13. Okay. This one we might need your calculator. Use your calculator. What is 5 squared plus 12 squared? 169. Yes, 169 is 13 squared, right, everybody? So, now if I give you another one, I put 39 and 15, and then what is the remaining one? Yeah, exactly. Because these and this, they just multiply by 3 of all the sides. Hey, everybody? Okay, so one problem, I actually teach you like more. So you can follow this trick and do so many different examples. Okay, let's see. Okay, how do we use the calculator? Okay, so everybody take out your calculator. Do you know your calculator? You can set radians or degrees, right? Now we can compute the trig function. Sometimes if you see a degree, it means you need to use degree mode. So if you don't see the degree symbol, you use radian mode. Is that clear, everybody? Mm-hmm. So, everybody take out your calculator. Do you see so make sure your mode is in degree mode. And now you press the sign. Enter 159.23 degrees. And enter. What is your answer? You all get your calculator. So please bring your calculator to class all the time. Mhm. So, okay. Give me 4 decimal places.
0.3546.
Thank you. Do you all get the same answer? Mm-hmm. Good. So that is sine. Okay. And now cosine. Do you use a question? Let's see. Yeah, this degree and then
Yes.
okay. Okay. So this degree and then everybody find the degree radian sign. Okay, here. So you press this. Oh, this is. Oh, interesting. Okay. Mm-hmm. Yes. Okay, so here. You press this, and then you see degree and radian. And switch that. And then right.
I said it again.
Yeah. Yes. You get it? Mm-hmm. Okay. So what is your answer? Give me 4 decimal places. Thank you. Okay. Now, radian. Go to the mode. Okay, your degree change the degree to radian. And then press tangent. 17 pi. Do you have a pi button on your calculator? Yes. And then over 6. Give me 4 decimal places. Thank you. Okay, let's stop right here and continue Monday. Okay, so please bring this hand out, and also please print out 7.3 on Monday. Okay, so we might finish 7.2 in the middle of the class, and we will start 7.3. And remember to do your homework. Okay, submit your first attempt by midnight, and then you can continue to work on your homework and improve your scores. Have a good weekend.